Hi YouTube, welcome back to my channel, or welcome if you're new. I am Channie and today we're watching the most extreme explosion in the universe by Kurzgesagt in a nutshell, live on twitch.tv/Chanzonia. Do join us next time. It would be fun to see you there. Let's just get to it. I kind of thought it would be the Big Bang, but I don't know, maybe they'll mention a different one. But yeah, let's see which is the most extreme explosion in the universe.
Supernovae are the most powerful explosions in the
Supernovae?
universe, unleashing enough energy to outshine galaxies. We have no real metaphor for their power. If the sun were to magically go supernova,
Wait, I need subtitles. Teehee.
it would feel like you were being hit by the energy of a nuclear explosion every
Oh
second
my,
for weeks.
4 weeks?
While supernovae are the engines of creation, forging the elements that enable life, they also burn sterile whole regions of galaxies. So what would happen if one hit Earth?
Dum 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 dum. I love this intro so much.
There are, roughly speaking, two ways to make a supernova. Either the core of a massive star implodes, or, less common, a white dwarf gains mass to the point where it ignites explosive nuclear fusion. The outcome is the same, a supernova explosion.
It goes
When we
boom.
think of an explosion on Earth, we think of something that happens fast and ends. But a supernova is more like a volcanic eruption followed by a tsunami. At first, there's a colourful ball of hot, expanding gas, creating a spectacular cloud that will shine for about a month. But then it doesn't stop. Hot and dangerous gas rushes outwards at speeds of 10,000 kilometers a second through the near vacuum of space, sweeping up the sparse gas of the galaxy. This wall of gas expands for tens of thousands of years and will eventually span up to dozens of light years until it finally cools off and disperses its substance back into the galaxy. So what if this star tsunami hits us? Well, the damage depends on how far away it is.
Yeah.
Stage 1, thousands of light years away. Humans have witnessed dozens of supernovae, but all of them were thousands of light years away. They appeared as new stars, some outshining the moon, twinkling for a few weeks, and disappearing. Aside from looking very pretty at this distance, they don't do much to us. Stage 2, 300 light years away. Things begin to get a bit icky once a supernova occurs around 300 light years away. We can expect one this close to us every few million years. A single star giving the night sky an eerie glow like twilight. And while this is far enough away and dim enough to not do harm to us, they can affect the Earth. At these distances, it's like being hit by the last weak waves of the star tsunami. Not strong enough to do real damage, but still noticeable. In fact, we know that over the past 10 million years, multiple supernovae have struck Earth from these distances because we can find radioactive isotopes of iron deep in the rocks and sediments at the bottom of the ocean.
Whoa,
Amazingly,
that's cool.
these supernovae around the solar system have cleared a 1,000 light-year wide pocket of space that's called the local bubble. They blew away the...
What effect does that have on the ocean, though? These, what do you call them?
Have struck Earth from these distances because we can find radioactive isotopes of iron deep in the rocks and sediments at the bottom of the ocean.
Do they affect the ocean
these
at all?
supernovae around the solar system have cleared a 1,000 light-year wide pocket of space that's called the local bubble. They blew away the interstellar gas and dust, creating a lumpy wall of gas that's now a cradle for star formation. Stage 3, 150 light years away.
Now we're a little too close
Once a
for my
supernova
liking.
happens much closer than 300 light years, we're approaching the zone where it does real damage. Stars
not really. Most isotopes don't radiate much anymore. Oh,
have extremely powerful magnetic fields. When they die, the tsunami of dead star actually retains a lot of this magnetic energy woven through the shockwave that expands outwards. In this highly magnetized cloud, we get conditions like in a huge particle accelerator that's accelerating charged particles like protons, nuclei, and electrons to immense speeds. Which means we have an expanding cloud that is shooting deadly radiation in all directions long after the bright light from the initial explosion has faded away. If a supernova happens too close by, waves of these cosmic rays will wash over the solar system for thousands of years. While we're mostly protected on Earth's surface by the atmosphere and ozone layer, the influx of extra radiation will still increase cancer and mutation rates. Not enough to cause a mass extinction, but it will be noticeable. Spaceflight would become impossible in the solar system as astronauts wouldn't survive the waves of radiation for long. We don't know exactly how bad this would be, but a supernova that is close enough may trap our species on Earth for generations, maybe thousands of years. It only gets worse from here. Stage 4, closer than 100 light years. Within 100 light years, things get bad, as a supernova disrupts our climate in ways that we don't fully understand yet. There are a few unpleasant things happening all one after another. First, the high-energy photons arrive from the explosion, followed by many decades of radiation from the radioactive tsunami, both of which seriously damage the ozone layer, Earth's shield against harmful radiation. The ozone layer absorbs ultraviolet radiation by breaking apart ozone, O3, into O2 and a free oxygen atom, which later reforms back into another ozone molecule. But the supernova radiation breaks up nitrogen molecules that gobble up the free oxygen, breaking the cycle and depleting the ozone layer quickly. Without a radiation shield, everybody living on the surface is exposed to very high levels of UV radiation from our sun. Cancer rates would skyrocket, and just going outside during the day could be life-threatening. The extra radiation will also kill a lot, if not most, of the plankton in the oceans that live near the surface and are the basis for the marine food chains, leading to a mass extinction. Worse still, supernova radiation.
How about like the deep ocean animals though? Would they, because they're quite far down, how would that affect them?
Would ionize gas in the atmosphere, which means that it would punch through molecules and knock electrons
I guess
off
it
nuclei,
would too, because you know,
charged.
less things to feed on, since everything else above them is dying.
For
but
water vapor to gather and form massive global clouds. In the worst case,
other
they
than
would
that,
reflect enough sunlight to trigger an ice age. In fact, it's thought that the ice age 2.5 million years ago was caused by a supernova. Some scientists even think that a supernova about 60 light years away might have been the cause of the Devonian mass extinction 350 million years ago. But wait, there's more. The electrons punched free by the radiation form enormous electric avalanches, or in other words, lightning. Earth is hit by some of the worst thunderstorms in millions of years. The intense lightning causes global wildfires that consume forests and crops, devastate cities, disrupt our electrical grids and global supply chains, all while a decimated ozone layer leaks deadly radiation. While in the past the ecosystem may have bounced back from a nearby supernova after a few thousand or million years, there's no guarantee modern civilization can take a hit of this magnitude. We would face food shortages, skyrocketing prices and wars as nations struggle to not be consumed by chaos. So a supernova this close would at the very least do significant damage for hundreds or thousands of years, if not end our modern civilization, and with it millions or even billions of lives. Still, humanity would likely survive and could recover.
Could survive?
Stage 5,
likely
closer
survive?
than 25 light years. A supernova closer than 25 light years means that we're in its kill
surely now humanity is cooked. Surely.
Radius, where a mass extinction.
Wait, did he say likely to survive or likely not survive?
Not
surely I
end
didn't
our
miss
modern
that.
civilization and can damage for chaos. So a supernova this close would at the very least do significant damage for hundreds or thousands of years, if not end our modern civilization, and with it millions or even billions of lives. Still, humanity would likely survive.
Survive.
Stage 5.
Now this time for sure we're not surviving, right?
A supernova closer than 25 light years means that we're in it.
Us surviving this far kind of scares me. Like, what? It's a little too close. Why are we surviving? Are we like roaches?
It's kill radius, where a mass extinction is all but guaranteed. Probably about half of the ozone layer would be destroyed, and massive climatic disruption on a scale we've never witnessed would ravage Earth. Entire ecosystems would swiftly be wiped out by radiation as global wildfires envelop the planet. All the things described before happen, but way more intensely and much faster. A few people might survive for years in bunkers if they have food supplies, but the world they return to will be devastated and hostile to life for hundreds of thousands of years. Human extinction is extremely likely. The final stage, 4 light years. Being any closer to a supernova is very unlikely because space is big. but the effects would be extreme. Even from 4 light-years away, the distance to Alpha Centauri, a supernova would be almost as bright as the sun in the sky. While casting 2 shadows could be fun for a few hours, within days the Earth's surface gets as hot as a sauna, baking the surface for weeks until the explosion fades. The surface of Earth burns, scoured of life. Even the oceans aren't safe. The massive amount of radiation that follows burns away the ozone layer, killing everything that sees sunlight. It would be the largest extinction event in history, reducing life to a few survivors in the deep sea and critters in the deep soil. Life basically has to start over. Conclusion. How worried do you need to be?
Not worried at all.
So, should you worry?
No.
Fortunately, there are only a handful of stars that may explode within 1,000 light-years of Earth, and none are close enough to be a serious threat.
Thankfully.
Even better, these stars will probably not go supernova for many millions of years. So
just
you
vibing.
are safe. But there's no guarantee for the far future.
No stress.
As stars orbit the galaxy, our descendants may find themselves dangerously close to a supernova. But by then, a far more advanced and wiser humanity will hopefully be able to just move out of the way.
Move out of the way is crazy. Moving the whole solar system out of the way.
Under the beautiful night sky.
Oh. That was a really interesting video. I love learning about space and these kind of things. You already know. Thankfully, we don't have to worry about no supernovae happening anytime soon near us at all. Future us, future humans in the many thousand millions of years, maybe they have to worry a little bit, but surely they would have figured it out by then. Surely, right? Surely. Make sure you like, comment, and subscribe, and I'll see you guys in the next one. Bye.